class, in this video, we're going to be looking at divisibility. The learning intention of this video is we're going to know the meaning of the terms divisible, and these are the terms over here which we've previously covered in other lessons. We're going to understand that the divisibility test can be used to check if a number is divisible by another. And finally, we're going to be able to test for divisibility by the numbers 2, 3, 4, 5, 6. We skipped 7, 8, 9, and 10. What we're going to be doing first is we're going to be unpacking several key vocabularies. So the only words that you don't really know so far is this word over here, which is divisible. We said that something that is divisible is when it can be divided without any remainders at all. And I've previously shown you the relationship between dividend, the divisor, and quotient. We said that the dividend is essentially the number that you are dividing. So that over here, I've included that definition down below. This number here, the second number, is referred to as the divisor. The divisor is a number that divides the dividend into equal sized groups. And the answer of that is what we refer to as the quotient. So we said that a number is said to be divisible by another number if the remainder is 0. So when you divide a number and the remainder is 0, therefore that number that you would divide in this case is therefore considered to be divisible. So for instance, let's look at these examples over here just so you have a better understanding. So true or false? 16 is divisible by 2. This means 16 can be divided by 2. Is this true or is this false? Well, we know that if we were to divide 16 by 2, that will give us a nice whole number. This would give us 8. If it gives us a whole number without any remainders, therefore it is divisible. So in this case over here, 16 is divisible by 2. So this is a true statement. Down below, 16 is divisible by 3. Can 16 be divided by 3 into a nice whole number answer? Well, it cannot in this case. So therefore, this is going to be false. 16 is divisible by 4. This is also going to be true because 16 divided by 4 gives you 4. So a nice whole number again. 16 is divisible by 5. This would be false because this doesn't give you a nice whole number. Not only that, but you could also say that the numbers 2 and 4, if something is divisible, that means the numbers 2 and 4 are therefore considered to be factors of this. And again, I'm just trying to show you how does factors and divisibility relate to one another. So now, to determine whether a number is divisible by another number, what we could do is we could actually perform the division algorithm to see if there are no remainders. So this is the proper method that you should be undertaking when you have large numbers. However, if the question doesn't really want you to actually solve it, and the question just asks you, is this number divisible by 3, we can actually avoid doing the actual long, tedious calculations, but instead we could actually do some quick, short, simple divisibility tests, which will allow us to determine whether that number is divisible or not, with the exception of 7. Okay? So let's now look at some divisibility rules. So for the first one, we're not going to be looking at a divisibility rule for 1 because all numbers can be divided by 1. So we're going to be looking at number 2. We said that a number is divisible by 2 if the last digit is even. So when it ends with a 0, 2, 4, 6, or an 8. So this is a fairly easy one over here. Check if each of the following numbers is divisible by 2. This over here ends with an 8. So therefore this is divisible by 2. 241 is an odd number, so this is not divisible by 2. 873 is also an odd number, so this is not divisible by 2. 466 is an even number at the end, so therefore this is divisible by 2. This also has a 0, so this is divisible. This is an odd number, so this is not divisible. So this is pretty straightforward. Alright, on the other hand, this is a bit new to you guys. So the divisibility rule for 3, we say that a number is divisible by 3 if the sum, so the word sum means if you add up all the digits of the number, that number should be divided by 3 without any remainders. So let's look at an example over here. So the example reads, is 354 divisible by 3? So what we do is this number over here contains the numbers 3, 5, and 4. This says you need to actually add all those digits and see whether that answer can be divided by 3 without any remainders. So 3 plus 5 plus 4, that gives you an answer of 12. This statement over here, up above, says that you need to see whether that answer can be divided by 3. Can 12 divided by 3 into a nice whole number? Well, in this case, it can, because if you went 12 divided by 3, that will give you 4 as an answer. So therefore, it is this is yes, it is divisible. So therefore, 354 is divisible by 3 in this case. We're going to look at some more examples of here, just so you have a better understanding. So check to see if the following numbers is divisible by 3. So 627, again, what I want to do is I want to add up all the individual digits together. So 6 plus 2 is 8. 8 plus 7 is 15. Now, we need to see whether the answer that I've got over here can be divided by 3 into a nice whole number. 15 divided by 3 is equal to 5. So therefore, this means 627 is divisible by 3. So that's why I have a little tick sign over here. 4002, again, what I'll do is I'll add 4, 0, 0, and 2. That will therefore equal to 6. 6 divided by 3 is equal to 2. So again, a nice whole number. So therefore, in this case, 4002 is also divisible by 3. 3278. So add all these numbers together. This gives me 20. 20 divided by 3 does not give me a nice whole number. So therefore, this number over here is not divisible by 3. 37,782. Add all the numbers together. This gives me 27. 27 divided by 3 gives me 9. So therefore, in this case, this number, it should be a tick over here. So therefore, 37,782 is therefore divisible by 3. We're going to be looking at the next rule. So a number is divisible by 4 if the last 2 digits of the number is divisible by 4. So that means it can be divided by 4. So look at this number over here. I've got the numbers 824. It's asking, is it divisible by 4? All I really care, if I want to see or check or test for the divisibility by 4, I only look at the last 2 digits. In this case over here, that's going to be 2 and 4. So in this case, 24. Is those 2 digits, can they be divided by 4? Well, we know that 24 divided by 4 is equal to 6, a nice whole number. And since we don't have any remainders or any decimals whatsoever, therefore this indicates that 824 is therefore divisible by 4. Again, a few more examples for you to actually complete or do, just so you have a better understanding. So we only look at the last 2 digits. 22 in this case over here, cannot be divided by 4. This gives me a decimal answer, so therefore there's remainders in this case. So therefore in this case, 1222 is not divisible by 4. 3421, the last 2 digits is 21. 21 cannot be divided by 4. Again, this gives me decimals, so therefore this number is not divisible. The last digits over here is 12. 12 we know is divisible by 4, so therefore this number is divisible by 4. And in this case over here, this reads out as the number 8. 8 is divisible by 4, so therefore this number is divisible by 4. All right, moving on to the next one. So this one is pretty easy, and I think something that you already know. A number is said to be divisible by 5, so it can be divided by 5 if the last digit ends with either a 0 or a 5. In this case, 99 would therefore be no. 875 would be yes. This one would be yes. This one would be a no. All right. This is another new rule that you probably are unfamiliar with, and it reads out: a number is divisible by 6. So any number can be divided by 6 if it's also divisible by both. That's the key word over here, by both 2 as well as 3. So let's look at an example to see whether this particular number is divisible by 6 or not. So what I want to be doing is I want to test for divisibility for 2 and 3 if I want to see whether this can be divided by 6. So I want to just set up my working out like this, just to show the test for divisibility for 2 and 3. So we said that something is divisible by 2 is when the last digit is an even number. So in this case, it's 114. 114 is an even number, so therefore this passes the check. It is divisible by 2. Let's look to see whether this is divisible by 3. So we said to test for divisibility of 3. I keep mispronouncing it. What we do is we add up all the digits together, and if the sum is divisible by 3, then therefore this number is divisible by 3. So if you add 1, 1, and 4, this gives you 6. 6 can be divided by 3. So therefore, this indicates that this number 114 is divisible by 6. By 3, I mean. And since it passes both of these tests over here, therefore 114 is divisible by 6. We'll look at an example of where one of these conditions are not divisible, so therefore 6 is not a divisor in this case. So this number here, 51, is an odd number over here, so therefore this does not pass the divisibility test for 2. So this does not pass it. However, if you add up all the digits of 5 plus 1 is equal to 6, this can be divided into 3. So therefore this passes this test over here. But since both of these are not passes, therefore this does not pass the divisibility test for 6. Again, I want to stress that there is no simple, there is a divisibility test, but it's not a very simple strategy, so therefore we're going to skip that. So just please remember there is no divisibility test or rule for the number 7 at all. Moving on to the next one, which is 8. So a number is divisible by 8, so it can be divided by 8 if the last 3 digits can be divided by 8. So in this case over here, the last 3 digits of 19,640 is 640, which is why I've set up my layout as such. Now what I do is I'm going to be applying my division algorithm to see whether I get a nice whole number or not, and to see maybe I might end up with remainders. So how many times can 8 go into 6? That would be 0. We then write the remainders next to the next digit. So therefore this number over here now becomes 64. How many times can 8 go into 64? That becomes 8 without any remainders at all. How many times can 8 go into 0? That would be 0. So therefore our answer would be 80. Notice that you've got a nice whole number here without any remainders. Because you got no remainders at all, this indicates that 19,640 is divisible by 8. Look at the next example over here. A number is divisible by 9 if the sum of all the digits is divisible by 9. So I'm going to add 7101 together. So if I do that, I'm going to get an answer of 9. And if I go 9 divided by 9, that is equal to 1. So therefore, because I'm getting a nice whole number, this indicates that 7,101 is divisible by 9. And lastly, the last divisibility test, which is 10, which is one of the most easiest ones. A number is divisible by 10 if the last digit ends with a 0. So therefore, this is not divisible at all because this ends with a 5. This is not divisible. This does. This is divisible. This is divisible. This is not divisible. So this is pretty straightforward over here. And just to summarize what we just kind of went through, this is pretty much all the rules over here for each number. So starting from 1 all the way to 10. We didn't go through 1 before because as I said, all numbers can be divided by 1, which is why we've skipped it. Then we went from 2, 3, 4, 5, 6. We skipped 7 because we said that there was no easy divisibility test for the number 7 at all. So what you could do is you could also copy down this particular table over here, or otherwise copy down all of the individual examples or notes from the previous slides if you want to do that instead. Once you've done that, what I'd like you to do is I like to go through one last example before I get you to answer some textbook questions by yourselves. So this question says, carry out the divisibility test on the given number and fill in the table with ticks or crosses. So this is the number over here. So you've got 48,569,412. Is it divisible by 2? Well, yes, because the last digit is an even number. So this passes the test. Is it divisible by 3? Well, to do that, remember what we do is we add up all the digits together, and if that sum can be divided by 3, this indicates that that particular number initially is divisible by 3. So if I do this, this will give me an answer of 30. 30 divided by 3 is equal to 10, a nice whole number. So therefore, this also passes the test. We said that a number is divisible by 4 if the last 2 digits is divisible by 4. In this case over here, that is 12 in this case. 12 can be divided by 4, which gives you 3. So therefore, this also passes the test. In this case over here, this number is not divisible by 5 because it needs to end with a 0 or a 5. So therefore, this does not pass the test. We said that something is divisible by 6 if it passes both these two tests over here. In this case, they did. So therefore, this passes this test as well. We said that something is divisible by 8 when the last 3 digits can be divided by 8 without any remainders at all. So the last 3 digits in this case is 412. So let's see whether 8 can go into 412 evenly. So if I perform the division algorithm, how many times can 8 go into 4? That'd be 0, remainder 4 in this case over here. How many times can 8 go into 41? That'd be 5 times with a remainder of 1. How many times can 8 go into 12? That would therefore be 1 with a remainder 4 in this case. And because I'm getting remainders, therefore this indicates that this number is not divisible by 8 whatsoever. The second last one, divisible by 9. So therefore to find out whether it's divisible by 9, it's very similar to the divisibility test by 3. So what we do is we add up all the digits in the number and see whether that can be divided by 9 or not. So in this case, if we add up all the number like our previous example, that gives you 30. 30 cannot be divided by 9 evenly, so therefore this fails that test. And lastly, something is divisible by 10 if it ends with a 0. In this case, it doesn't, so therefore this doesn't pass the test at all. Alright, again, what I'd like you to do is I'd like you to please pause this video right now and please copy down this particular table inside your exercise book and complete this. This should take you about 5 to 10 minutes. So what you need to do is you need to provide an explanation as to why the number 2 is either divisible or not divisible for the number 462. So please pause the video right now and then compare your answers with mine. Alright. If you've actually answered this particular question, what you should obtain for this is we should say that 462 is an even number. So therefore, because this number is even, 462 is therefore divisible by 2. To test if it's divisible by 3, what we do is we add each individual digit. Therefore, this equals 12. And if that sum can be divided by 3, therefore 462 is divisible by 3. In this case over here, the sum of 12 is divisible by 3, so therefore we will say this is divisible as well. To test whether this is divisible by 4, we look at the last 2 numbers, so 62. 62 is not divisible by 4, so therefore we will say this is not divisible. This doesn't end with the number 0 or 5 at all, so therefore this is not divisible. Is 462 divisible by 6? To do that, it must pass the test for number 2 and number 3. In this case, it did. So therefore, this is considered to be divisible. For 8, we look at the 3 last digits and see whether that can be divided by 8 without any remainders. If we do this by hand and you do this in your exercise book, you will find that you will get remainders. So therefore, 8 is not divisible at all. For 9, we'll add all the numbers together and see whether that sum can be divided by 9. So if you add up all the numbers as you've done previously, 12 cannot be divided into 9 at all. So therefore, this is not divisible by 9. And lastly, to test whether it's divisible by 10, the last digit must end with a 0. In this case, it doesn't. So therefore, this is not divisible. So this is how you should be answering your responses. Alright, what I'd like you to do now is I'd like you to please answer these questions over here from exercise 3C, which can be found in page 124 in your textbook. So I want you to answer questions 1, 2, 3, 4, 5, and 6. When you answer question 2, all you need to do is answer every second question. So what that means is answer question A, skip B, answer C, skip D, do E, and so forth, so forth, so forth. So you don't actually have to do too many questions as they get a bit too repetitive. This should take you about 20 to 25 to 30 minutes or so, so between those time frame. So please give yourself that time to answer these questions over here. Make sure you are writing down the actual questions. You don't need to write down the sentences over here, but make sure you are writing, for instance, 1A, 21,735 divided by 3, and then show me the actual working out as well afterwards. Once you've actually done that, these are the solutions that you should arrive to. So please grab a red pen now and check whether your answers are correct. After you've actually done that, what I'd like you to do for the final few minutes of today's lesson, I'd like you to please log on to Google Classroom to complete this exit ticket. This exit ticket only comprises of 14 multiple choice questions, which shouldn't take you too long to answer. It'll probably take you about, I think, 5 minutes to answer 14 questions because I think the questions are quite easy, and this will give me a good snapshot to see whether you've actually understood the topics covered in today's lesson. This is the end of today's video. I hope you guys found this video to be very helpful. Thumbs up if you liked it. See you in the next video. Bye.